During my last discussion, we have discussed on geotechnical engineering out of textbook, not within the framework of textbook. Out of textbook, we have discussed geotechnical engineering, and we discussed up to certain extent. Today, I shall discuss about the settlement of foundation. Mostly, there are three types of settlements. First is immediate settlement, second is elastic settlement, and third one is compressible settlement, that is long-term consolidation settlement. In addition to this, another settlement is there. This is distortion settlement. In case of clay soil, elastic settlement and consolidation settlement, that is primary settlement and secondary settlement, is a governing factor. Whereas the immediate settlement, in case of clay, it is not simply noticed. However, in this granular soil, where pore water can easily be oozed out, that is nominal loading, that type of settlement is there. That's the immediate settlement. In case of sandy soil, that is granular pervious soil, the immediate settlement appears to be completed during the construction work itself. In some cases, it is also noticed that during the coming up to the plinth beam level, there is some amount of settlement, those are which are heavily loaded columns, and some very negligible amount of immediate settlement are generally noticed, which are slightly loaded. Whatever it may be, there are a lot of equations in different textbooks, different codes, and basically in our India we give more importance on Indian standards. The elastic settlement is normally estimated out loading pressure, weight, influence factor, and elastic modulus. This is the equation, the elastic modulus. This elastic modulus we can determine from the laboratory test results and from wet load test also, and from N value also. Bowles, Scott, and many other established some empirical relationship between elastic modulus with that of standard penetration test and cohesive strength. This is the one equation, this equation, or this is one equation. In this equation, using N value, we can estimate the elastic modulus. From cohesion also, we can calculate the elastic modulus. And for N value also, there is another equation. And all these equations are very commonly used. My humble suggestion to you, besides calculating the elastic modulus from the laboratory compression test, we should cross-check it with the field values also, so that there may be expected to be some error or something other influence factors is there due to pressure increment in laboratory compression test, preparation of soil samples. So consider all these factors. We should cross-check it from this empirical relationship to confirm whether our value is almost same. There may be variation, but variation should not be more than 50%. If it is within 10% or 15%, any one value we should adopt. But in case of 50% variation is there, it is very unwise to use that value. From this equation, after calculating the settlement, we can rearranging this equation, we can calculate the base pressure also. That is, base pressure means our pressure intensity, which we normally call as P. That is SBC. The important factor, that this I is important factor 0.85 for circular base and 0.95 for square base. In case of rectangular foundation, we should convert the rectangle to equivalent circular base. Using the calculating the area of the rectangle convert to circular base, we can use for circular base, or we can go for square base also. It will be easy. Otherwise, rectangle, say it is 2 meter by 4 meter. If we consider B as a 2 meter, our settlement will be much less. And if we consider 4 meter as a width, then it will be almost double. So we should calculate it. We should calculate this rectangular base in either to circular base or to square base. And this Poisson ratio, we can calculate from laboratory compression test also. And normally in case of soil, it is always within the range of 0.5 to 0.5 to 0. Normally less than 0.5, it is more hard soil, maybe less than 0.5, and more soft soil, it will be more than 0.52. As I said, foundation settlement is defined as the gradual vertical deformation, that is compression of stress soil. The soil below the foundation base under constant and continuous loading. The settlement is a resultant of decrease of voids due to structural rearrangement of particle grains under confined conditions and mineral skeleton breakdown. However, some water generally used out in the process of void decrease since water particles are incompressible. In the process of settlement, the Darcy's law of permeability is also applicable. However, in later age, it was established that there may be a settlement without oozing out of any amount of soil or water. Generally, voids filled with water or air, and air may also ooze out during loading. So, in consideration that Darcy's law is not applicable, I have already said there are long-term settlement, that is consolidation settlement, and elastic or initial settlement, and another is immediate settlement. Elastic is due to elastic modulus of soil. Immediate settlement is due to overloading. That means originally there is a surcharge, say about 1 ton at the foundation depth, and we added 1 plus 15 ton, that is 16 ton overloaded, there will be some particle rearrangement. So due to particle rearrangement, the immediate settlement will be there. More important thing, the Foundation Committee of International Geotechnical Society has decided that the settlement should be avoided in public discussion because it may disturb the peace of mind of those who are to be charged. It is, it is very important. As far as possible, we should not discuss the settlement process before the builders, before the clients whom we are going to charge. They may fear, they may feel panic. Yes, there are a lot of old settlement histories like the uh, Pisha Tower, Kutub Mina. There are a lot of studies going on. Still, there are a lot of uh, scholars studying all these things. Even after rehabilitation, also all uh, scholars they are still studying. Anyway, nowadays settlement due to soil heap or lateral displacement are also considered, and this type of settlement is called distortion settlement. This is distortion settlement. This is soil heap. This is the soil heap. Because if there is no adequate surcharge, if side of the foundation, if there is no adequate surcharge, then this there shall be soil heap, and due to increased pressure, there shall be soil heap, and this original ground line shall be distorted in this way. So this foundation shall settle, and this settlement is called distortion settlement. This compression and tension plan, same that of steel or concrete. However, in soil, in long-term heap surface takes a regular shape for which no rebound effect takes place even after complete release of load. Immediate settlements cannot be coming up. After immediate settlement, the soil is not coming up. But if we go for the plate load test or some foundation load test, after completion of load test, when they release the pressure gradually, we we are generally get some rebound settlement. At zero loading, we shall be getting some rebound settlement. We are terming it as rebound. That means this soil surface which was settled is coming up. And in our calculation, we have neglected the rebound. For our basic analysis, we are always neglecting the difference. Our computed settlement should be total settlement at peak load and minus the rebound. However, in sandy soil, this type of rebound settlement are very less. Since soil and rearrangement of particles, normally it gains that permanence or that con- conditions, there will be rebound effect will be very less. This may, in clay also there may be less rebound. This may be a thixotropic loss of strength and distortion exceed the surface tension limit. In short time, it is not possible to discuss. However, I am trying to aid here that any structure shall settle either marginal or exceptional, either uniform or differential, and the settlement is the uncomfortable phenomenon in foundation design. Neither it can be predicted nor it can be accurately estimated. In some structures, settlement takes place after several hundred years. In some in some structures, settlement may continue throughout the entire lifetime of the structure. In some cases, settlement reported completed during construction period itself. The settlement behaviors depending upon the loading pattern of the structure and soil formation and its behavior. See, here you see the settlement of shallow foundation may be estimated using various methods like that of shale pipe, and most popular methods are from shear test, one-dimensional consolidation test, plate load test, SPT values, and there are some other methods which are not popularly and commonly used in general practice. When we make some pit, since I was associating with many construction projects in our northeastern region, the duties of geotechnical engineers and geotechnical consultants not only limited to submitting of this investigation and submitting the design parameters, but basically we have to look after the project during construction period of the foundations, during excavation of foundation trams, and we have to tackle all the problems during excavation of foundations and construction of foundation. There may be some soil blowing, soil heave, soil slopes. There are a lot of problems. So, in my notice, there are some foundation branches I noticed that soon after excavation, the surface are very smooth and it is a very plain surface. But after few days of excavation, at the outside margin of the foundation, that the origin and shape is alright, but the middle portion of the foundation is slightly heavy, because of the weight of the surge is there. So it is this base nearer to the cutting edge, this base is remain constant, and mid portion the soil heap is noticed. So bottom surface heaps are normally noticed if we keep the foundation for several days. After excavation for several days, then the middle portion seems to be slightly heaped. And there is another aspect what I see, what I observed personally, when a foundation, if after construction, if we fill up the, if we made the backfill with loose material, there is chances of soil heap below the foundation. But when we compacted the backfill material properly, we are, there is no settlement was noticed. Another important aspect, during estimation of our soil pressure, the surface component, especially in sandy soil, the surface component is much much more, and only governing factor. When C is 0, the cohesion factor will be automatically 0, only there shall be surcharge factor, and this net overburden pressure shall produce if we properly backfill with original state of compaction or more than that. If we can compact more than that, there will be less settlement. When we just putting some excavated material, then there will be chances of the distortion settlement under the foundation. So I always suggest, I am where I am going, I am always saying that the backfill should be made with crusher dust or stone dust. There is some advantage of using crusher dust. Crusher dust can be compacted up to the required density, about 90% or more, underwater conditions with very nominal compaction effort. Number two, the crusher duster, this crusher stone dust or crusher dust, the particles are much heavier than the clay particles or silt particles or sand particles. Crusher dust particles are much heavier, so it is very which help immediate compaction and consolidation, and more than 90% compaction too. Another important advantage is low, very low annular space, since these are mostly these are in angular in shape, and good water absorbing capacity, which help mobilization of greater shearing resistance. Next advantage is all individual particles of crusher dust are hard enough, which is not which is easily not shareable. Overall quality of the crusher dust is crusher dust has a adapting tendency like silt. Silt has adapting tendency. If we mixed with sand, it became loam, that is sandy silt. If we mixed with clay, it became silty clay. So crusher dust is the best suitable material for foundation backfill to minimize the misfortune and unpredictable uh, damage of structures due to settlement. Plastic clay is also suitable for foundation backfill compaction using vibratory rollers. There are hardly any space between the soil cut face and foundation as I often notice where I visit. In case of manual ramming, in most of the places I saw that the manual ramming is going on where 70%, 60% compaction is there. But if there are small vibratory rollers are available nowadays up to 300 size vibratory rollers are there. If we use that type of roller, we can compact the backfill material up to the required amount, which we can assure that our structure is totally safe against settlement failure. The immediate settlement. Immediate settlement we can use with this settlement. With this settlement. From elastic with this settlement. With this equation, this is immediate settlement. And the consolidated settlement, it is using this settlement. Here, this rigidity factor, depth factor correction, that is a rigidity factor we have to, their rigidity factor is 8.8 for uh, bigger size foundation, say like long strip, or big size foundation, say 6 meter by 6 meter foundation. This rigidity factor is 0.8, and depth factor depending upon the depth of foundation and width of foundation. Width I have already stated earlier that either we should go for uh, square foundation or circular foundation at the time of calculation of this, especially for settlement analysis. Because rectangular foundation, if a lower dimension is give some lower result and higher dimension will give some higher result. So we must convert either to square shape or to circular shape. And this uh, lambda is, it is pore pressure coefficient, which is based on pre-consolidated state of soil, which we can calculate it from consolidation or consolidation pressure also, or there are some standard table also which gives almost similar values. And this consolidation settlement or secondary settlement, some say it is secondary settlement, some say it is time settlement, some say it is consolidation settlement. These equations are very popular everywhere. Now, I am going to discuss some empirical relationships of different codal provisions. This, this one is on the basis of E0 void ratio, another is liquid limit, another is water content. All these are empirical relationships. During my last more than 50 years, 5 decades, I am conducting several thousand consolidation tests for several thousands products, and we have calculated this empirical relationship also. My personal opinion, this void ratio based empirical equation is much better than all these things. All these things. To some extent, this increased moisture content equation is little bit reliable, but it is not at all reliable since same liquid having a soil, there may be a void of zero point 0.5 or there may be a void of 1. So in case of void 1, it will be very soft. So it may valid. This equation not valid. But if the void is very low, that means soil is very hard, then this equation is not valid properly. At the same time, there are some lot of another empirical relationships. If soil moisture is at equal to or very close to liquid limit, then the shear strength of that soil is less than 1.7 gram per centimeter square, and where this water content is equal to or less than plastic limit, the soil has shade strength almost 1.7 kg per centimeter square. So these are the these are also empirical equation, and these are also empirical equation. So one should be serious on selection of this empirical process of determination of CC. But in my opinion, this empirical equation gives almost similar value that of consolidation test results. And the pre-consolidated soil, there are another provision of calculating settlement of pre-consolidated soil, that is soil having envelope more than 35. This equation is necessary. This is pressure increment, and it is volume compressibility coefficient, thickness, RF, rigidity factor, depth factor, and lambda. This is almost uh, very comfortable. This result gives very comfortable results. In addition to this, plate load test, from plate load test also we can calculate the settlement, and that settlement we should convert it to different size of foundation based on the information getting from the plate load test results. There are a lot of empirical equations. There are many lot of equations, but Tarjaghi, Winterkorn, Peck, Hanson, Thunberg, Scott, and Bowles, they have mentioned that in case of C0, 50 soil, that means pure cohesive plastic clay, pure cohesive plastic fat clay, that is totally 50 soil. In the case of 50 soil, settlement correction directly be computed as a proportional to weight from the plate load test results. But in all other types of soil, there are uh, some standard equations. Say in IS there is an equation settlement of plate into the plate B, and that one equation is there. And in RIC also there are some, in original ASTM code also there are some assumption, some empirical relationship from uh, the previous history, and there are some textbook also. Some say that a B foundation width by plate width to the power n, and varies from 0.3 to 1. Like that, there are a lot of empirical equations. However, any equation except C50 soil, any suitable equation we should use. And I have estimated some different type of settlement, and I developed one equation also. I shall be discussing that chapter in later times. And from another value, from SPT value, we can calculate this settlement. That is IS 8009 Part 1, discussed in Rule 9.1.4. with a graphical representation. In that, in that rule, there are some specific guidelines. The settlement is proportional to shift soil pressure, which may or may not be. In other equations, this is not directly proportional. Settlement is dependent on foundation base for small foundation. For small foundation, there are very less chances of high variation, but for big foundations, there shall be a huge variation. We should not forget that. This for small foundation, it is almost alright, but for medium foundation, these are not good considerations to accept this provision. Water table has a governing role in settlement analysis. Yes, I do agree. Settlement uh, may increase due to saturation condition of the soil. And another aspect is the N value shall be weighted average N. The reliability is dependent on soil formation, most suitable for C0 soils only, as I told earlier. In settlement analysis, there are two important components: thickness of the compressible strata, pressure increment, and pressure increment calculating, we are calculating French mathematician Bacinac equation of stress distribution theory for circular foundation. He has considered the base as a circular foundation. That is B0, that means to be calculated is B plus Z, where B is diameter and Z is this. And we have to calculate the load of this area. Accordingly, pressure and increment at that point, that's the Q by B plus Z square. And he also suggested A is equal to 2B. That means if it is B, compressible thickness of the compressible stratum, Bacinac has suggested 2B. Thus, it is coming this way, and this is the equation. These are always these are all available in standard textbooks, UG and PG courses textbooks, which also given in some quotes also. In his theory, he considered the soil as semi-infinite, isotopic, homogeneous, and elastic bed. He also assumed that soil is weightless, soil is unstressed, soil has no independent weightless soil. Stress is independent of elasticity of the soil. My question is how soil is weightless. Is it possible? Everything in this universe has some amount of weight. There is nothing weightless. So, soil weight is there, and we are duly considered in everywhere. In considering this P also, we are considering this in this equation when settlement analysis on the basis of uh, compression index, in that log delta P by P0 divided by P0. So we are considering soil has some weight. I do not know why he is assuming that soil is weightless. Not only himself, but many others also saying the same thing as soil is weightless. But if soil is weightless, how, why, and what is the necessity of our using soil weight as a surcharge, as an overburden pressure in both SBC estimation and settlement analysis in excess pressure also. For what? Why? He also assumed that the load acts on a point along the CG line, and so this theory is also known as point loading theory. This is Bosinac point loading theory. Westergaard in 1938, much later than Bosinac, conducted model studies on Bosinac point loading theory, and he established that the horizontal strain is zero under loaded area and factor it is coming to this. And in 1943, Tajigai presented his findings, and this is equal in this equation where point is unit, P, this P is unit pressure intensity. Westergaard theory gives comparatively lower value than Bosinac equation, almost 70%. So most practitioners prefer to adopt Westergaard theory. Therefore, Westergaard theory is commonly used. In Westergaard theory, our thickness of the compressible stratum should be considered as 1.5, where in Bosinac equation it is coming to 2. So even myself, I prefer to adopt Westergaard theory, and thickness is coming 1.5 B. There are some graphical in on the basis of R by Z, radius of charcoal and Z is depth of points loading. So this Q by Z square IB, that is Bosinac constant, and this is IW is pressure intensity factor of Westergaard. It is Westergaard constant. We are adopting these for our computation purposes. Scott, after conducting extensive study, he proposed that the applied loads are uniformly distributed over the contact area, and load distribution angle beta is almost equal to 45 minus 5 by 2. 45 by minus 5 by 2 means it is, in case of sun, it is coming almost, it is 30 degrees. In most of the standard textbooks also, our, our former professor Dr. Bharat Singh and my friend Dr. B.G. Rao, we did some studies on these factors. In this increment factor, we find that this 30 degree angle, and most of scholars they are saying that this 30 degree is almost the equivalent to almost the angle of repose, and the soil behaves that according to dust angle of repose, so that beyond that it will fail. So this 30 degree is very comfortable. It is very comfortable. With this equation, we can find out the pressure distribution at this point to calculate the settlement. Which is coming, it is almost 0.3 to 0.4. In all this analysis, we have some governing rules. That the pressures has a relief of existing overburden pressure. So P equal to P minus Q, that is applied pressure minus existing overburden pressure. Constant maintenance of applied pressure till not balanced by upward force. They recommended that the applied pressure shall be constant up to 3B. That is, you see, in SBC analysis, while I was discussing on SBC analysis, I have said, so far I remember, I have said that there are some, this is if it is considered in Bosonath, considered it is 2B or 3B, but during analysis it is find that this is up to 30% of the depth equal to 30% of B, the same pressure shall be continued, same pressure. There will be no up to one third of B, there will be no change in pressure, same pressure will be there. Thereafter the reduction will be there. However, we are not slicing the soil formation in computation of settlement. We are assuming average of this. Otherwise, the same for say one third of this, the same pressure, this equal to P, Q equal to Q, and the rest will be distributed at 30-degree angle. So we are not going to that. We are taking a distribution angle as a 30-degree, and we are calculating accordingly. There is hardly any difference. I have calculated and analyzed. There is hardly any difference. Presence of thin layer shall be considered. It is some distinguished effect. Applied pressure distributed both vertical and horizontal direction. So we are calculating the load vertically acting, but there is a consideration. The applied pressure distributed both vertical and horizontal direction. Because of horizontal distribution, the vertical stress is decreasing. Because here horizontally means it is not equal to at the same elevation of foundation level, but it is distributed slightly horizontal, so we are considering it is 30 degree. However, if there is no overburden pressure or no surcharge here, there may be some heaving. Already I said there may be some heaving, so which is due to horizontal distribution of load directly. Neither groundwater nor shear strength of soil has any role in shear stress distribution. So stress distribution is independent. It will be distributing both horizontally and vertically, and distribution angle will be approximately equal to 30 degrees. Pressure bulk net distributed area is smaller in plastic clay and time dependent. Pressure distribution in sandy soil governed by soil permeability and particle grain size shape. That is 45 5 by 2 condition is valid. There are several methods of vertical stress analysis. It is appropriate to adopt average value of 5-6 method for better assessment. The following points are important in settlement analysis. Foundation may also settle due to loads of the adjacent structure. Foundation may also settle due to release of overburden pressure. Oversaturation of plastic clay may also produce uncomfortable foundation settlement. Foundation may also settle because of non-uniform loading. There are some structures are heavily loaded and some structures are nominally loaded. There will be uh, some settlement shall be there. And if we are assuming that the settlement is uniform according to the loaded pattern. That means unit area basis settlement is uniform. So in one member there will be uh, size shall be very small because of this uniform loading, and one uh, foundation member shall be quite big. So settlement must be different. So it is more difficult to maintain the differential settlement. Manage differential settlement and maintaining it is a very difficult. Once differential settlement started, there is very difficult to shift this structure. For some monuments, some historical buildings like Qutub Minar, Pisha Tower, or these purpose it is all right at any cost that can be saved. But for a building, rehabilitation cost, if it is equal to the building cost, then it is no point of rehabilitation. So once this differential settlement started, it is very difficult to manage and maintain. Foundation also settled non-uniform loading and irregular structures. What happened? Some of our, some clients, they have engaged some and they have collected some beautiful structures from uh, nowadays from net and other sources, and their structures are coming like this. You see, this is a, big open spaces, lower portion for car park and upper portion there are some hall type arrangement, and this is one building. It is a very big building, massive building. This rear portion of the building is starting about 180 mm, and this portion there will be no settlement. So later on, this building required to be strengthened with making some provision of additional piles, additional rows and columns of pile outside the building, and making connection with heavy reinforced concrete with all columns and beams. Then it is now safe. However, there are some uh, settlement failure stories with me. I shall discuss all these settlement failure these stories in my next discussion, and I hope it will help you. And if you have any problem, any question, then please feel free to post me at your disposal, and I am always available at jcgogoi@gmail.com. Again, I am saying it, jcgogoi@gmail.com. Please have a nice day. Thank you all.